Magandang araw po sa ating lahat. We will be solving several easy problems about DC motor efficiency na pwede nating gamiting basis hindi lang po sa ibang problem solvings kundi sa practical applications din in understanding the properties and operations of DC motors relating to efficiency. Tandaan po natin na hindi lang tayo nagko-compute ng problems. Dapat nire-relate din natin ang mga ito sa practical applications. Umpisan po natin sa unang problem dito. At full load, a 15 horsepower motor draws 54.8 amperes from a 240 volts line. What is the motor efficiency? In motors, mapa AC or DC man, ang output nila ay in terms of horsepower. So ibig sabihin po, itong 15 horsepower, ito na po yung kanyang power output. At sinabi dito sa problem na yung motor, it draws 54.8 amperes from a 240 volts line. So, ibig sabihin po, itong 54.8 amperes, ito po yung line current na papasok doon sa ating motor. Kaya madali nating makukompute yung power input neto, which is the terminal voltage multiplied that by the line current. That is 240 volts multiply that by 54.8 amperes. This is 13,152 watts. Yung power output, which is 15 horsepower, convert din po natin ito in terms of watts, wherein 1 horsepower is equal to 746 watts. This is equal to 11,190 watts. For the motor efficiency, we have the formula, percent efficiency. Ginagamit din po ang symbol na ito for percent efficiency. This is equivalent to the power output, divide this by the power input times 100%. Substituting yung mga values ng power input and output in terms of watts, 11,190 watts, divide natin ito ng 13,152 watts times 100%. Ang efficiency equals 85.08%. Dito tayo sa pangalawang problem. The shaft power of a shunt motor is 7.8 horsepower. It draws 50 amperes from a 120 volts. The field winding draws 1.2 amperes. What is the efficiency of the motor? Power output ng motor, that is 7.8 horsepower. Power output, 7.8 horsepower. Convert na natin ito into watts. 746 watts in 1 horsepower. This is 5,818.8 watts. For the power input, terminal voltage times the line current. Ang terminal voltage is 120 volts and the line current is 50 amperes. This is 6,000 watts. Kung tatanungin niyo siguro, saan gagamitin yung 1.2 amperes? Sa problem na ito, panglito lang po yung ISH na 1.2 amperes. Dahil according dun sa formula natin, ang kailangan lang po natin is the terminal voltage and the line current na binigyan na po sa atin, 120 volts and 50 amperes. Dahil may mga certain problems, nagbibigay sila ng mga given na hindi naman natin talaga kinakailangan doon sa required na value na hinahanap. Substitute na natin ito sa formula. Efficiency equals the power output divided by the power input times 100%. Power output 5,818.8 watts. Divide this by 6,000 watts times 100%. So the efficiency is 96.98%. Third problem, the input and output powers of a 220 volts shunt motor at full load are 30 kilowatts and 28 kilowatts respectively. The field and armature circuit resistances are 50 ohms and 0.012 ohm respectively. Determine its efficiency at full load. Gaya ng problem kanina, meron ulit siyang mga given na binibigay dito na hindi na natin kinakailangan doon sa required na sinusolve natin na efficiency. Dahil sabi dito sa ating problem, yung input and output ng motor na ito ay 30 kilowatts for the input and 28 kilowatts naman para sa kanyang output. So madali na natin masusolve itong problem na ito. Efficiency, again, power output, divide this by power input times 100%. Napaka-importante na habang tayo ay nagpa-practice mag-solve ng mga problems, sinusulat natin palagi yung mga formulas para hindi natin sila makalimutan agad-agad. Mas matatandaan natin itong mga to habang mas sinusulat natin sa ngayon. Habang mas ginagamit, mas naaalala natin. Substitute natin yung mga given. Power output, that is 28 kilowatts. Divide this by 30 kilowatts times 100%. Therefore, the efficiency equals 93.33%. Another problem here, a 15 horsepower motor has a total loss of 1,310 watts when operating at full load. Calculate the percent efficiency. The formula for percent efficiency is power output divided by power input times 100%. Ngunit gaya ng formula na ginagamit natin for DC generators, power input equals power output plus power losses. Pwede nating i-rewrite tong formula na ito in percent efficiency, power output, divide this by power output plus the power losses times 100%. Convert natin yung 15 horsepower na output into watts. Power output, that is 15 horsepower times 746 watts in 1 horsepower. This is 11,190 watts. Pwede na nating i-substitute ito at yung value ng power losses dito sa formula natin. Percent efficiency equals 11,190 watts. Divide this by 11,190 watts plus the power losses, which is 1,310 watts times 100%. This is 89.52%. Next problem, a 25 horsepower motor has an efficiency of 86.5% when delivering its rated load. Calculate the total losses. Hopefully, by this time, nasasanay na tayo that when we are speaking about motors, pag sinabi niyang 25 horsepower motor, ito na mismo yung kanyang power output. Dito sa problem na ito, given yung efficiency, ang kukompute natin yung total losses ng motor. Yung formula natin, efficiency equals the power output over power input times 100%. But again, yung power input can be expressed as power output plus power losses. Convert natin yung power output, 25 horsepower into watts. This is 18,650 watts. Substitute natin yung mga values dito sa ating formula. Percent efficiency equals 86.5% equals 18,650 watts. Divide this by 18,650 watts plus the power losses. Cross multiply. Ito pupunta dito sa taas. Ngayon naman, itong 86.5% pupunta naman dito sa baba. 18,650 watts plus the power losses equals 18,650 watts. Kalimutan po natin yung 100% dito, sorry. Okay? So times 100%, divide this by 86.5%. Simplify natin ito. This is 21,650.694 watts. 18,650 watts plus the power losses. Transpose natin ito sa kabila, magiging negative. Power losses equals 21,650.694 watts minus 18,650 watts. The power losses is 2,910.694 watts. Last problem. What is the horsepower developed by a motor when the armature current is 20 amperes? The applied voltage is 115 volts and the counter EMF is 110 volts. Ang hinahanap natin dito ay yung power output in terms of horsepower. Kung ang input ng motor, that is the terminal voltage times the line current, dahil ito yung pumapasok doon sa mismong motor, ang power output naman na matatagpuan doon sa armature, dahil ito yung nasa armature, kukunin natin yung kanyang voltage multiply that by the current. Ngunit ano yung voltage na gagamitin natin sa kanya? Hindi po pwede na yung terminal voltage or yung applied voltage ang gagamitin natin. Kung di, ang gagamitin natin dyan yung counter EMF ng motor, which is the voltage is the back EMF or the counter EMF, EC or EB. Yung current naman natin na kukunin, since that is the power developed inside the armature, ang gagamitin nating current ay yung armature current. We will be encountering this formula sa mga susunod na problems pa. So for the power output, lagay lang po natin dito yung formula. EC or EB, multiply that by the armature current. Substitute natin yung mga given. Yung counter EMF is 110 volts. Multiply this by the armature current, which is 20 amperes. Power output in terms of watts is 2,200 watts. I-convert natin ito into horsepower. In 1 horsepower, there's 746 watts. Cancel out dyan. Therefore, the power output is 2.949 horsepower, or this is approximately equal to 3 horsepower. We will be solving more problems about efficiency of DC motors in other videos. Maraming salamat po. Hopefully, meron tayong natututunan. Maraming salamat din po sa ating mga subscribers. Magandang araw po sa ating lahat.